Well, hello everybody. We're getting ready to start our notes on 1.2. We're going to be looking at parent functions. And we have 8 parent functions we're going to go through. The first, you probably recognize it, this is a linear function. And that's a linear function. The equation for a linear function looks like this. It's f of x equals x, meaning that every value of x is the same as y. That's why we have a line that goes through the origin and through the particular points it does. On this particular function, we find that the domain, which is your x value, and your range, which is your y value, are going to be all real numbers. So the domain is all real numbers, and that's, I call that kind of like a double R. Forgive me, that kind of messed up a little bit, so let me see if I can get that to look a little bit neater. Let's try this. 1 line, 2 lines around like that. There we go. All real numbers. In interval notation, that would look like this. From negative infinity to positive infinity with parentheses. And that is a negative infinity. It's not a pair of eyeglasses. Okay, your range also is all real numbers. And again, the interval notation is negative infinity to positive infinity, meaning the x's keep going forever, both negative and positive, and the y's do the same thing, negative and positive. Now, as a reminder, when you look at your x's and y's on a table, remember your x is your domain and your y is your range. Your x is your input and your range is your output. There we go. All right? So, the next one we're going to look at is a quadratic function. Now, you guys might remember this from Algebra 1, quadratic. Q-U-A-R-D, excuse me, I misspelled that. That was my fault, guys. Let's try that one more time. That looks a lot better. It's a quadratic function, okay? The equation for a quadratic function looks like this. It's f of x, that's f parentheses, x in the middle, close parentheses, equals x squared, okay? So, let's look at the domain and range of this function. As you can see, x is right here, and it's at 0, 0. That's as low as the function goes, okay? That's the lowest y goes on the function. The x's continue to go out both directions forever. So, x, the domain, is going to be all real numbers. And again, the notation for that is negative infinity to positive infinity, okay? Our next we're going to look at is the domain. Now, if you notice, the domain starts here, and all the y's are up. That means y, my range, is greater than or equal to 0. Okay? And in interval notation, that's going to be bracket 0, because if you remember in interval notation, when we have a greater than or equal to or less than or equal to, we use the bracket with that particular number it's denoted with. And because it goes to positive infinity, we do this and we have parentheses on that side. Okay? Remember, your quadratic is a U shape. It is called a parabola. It is U-shaped. It's going to be a little different from our absolute value. Excuse me, I lost my train of thought there. My absolute value function. Okay, so that's called the parabola. Okay, moving on. All right, the next one we're gonna look at, this is an absolute value function. So this is an absolute value function, A, B, O. And again, I'm a math teacher, not an English teacher, so you guys just forgive me on that. Absolute value function. That's V-A-L-U-E. Please forgive again my writing. Absolute value function, the equation looks like this. F of X equals the absolute value of X. Okay? Now notice this is V-shaped, okay? Looks a little different again, like I said, than the quadratic on the shape of it. But actually everything else is gonna be the same. Our domain, again, is all real numbers. All real numbers. That's gonna be, again, our interval from negative infinity to positive infinity. Okay? Our range, though, again, like with the quadratic, our range starts at 0 and moves up. So that means y is greater than or equal to 0. Another way to write that would be bracket 0, comma, infinity, parentheses. Okay? All right. And yet another way you could say that y falls between 0 and infinity. Those are just different ways you can write the interval notation on that one. Okay? All right. Let's look at this one. Now this might not be one you've seen before. This is a cubic function. Okay, so this is cubic. A cubic function. The equation for a cubic function is f of x equals x cubed. X cubed. Okay? So when we look at this, let's look at our x and y here. We know this is our x and this is our y. The x's continue going on, so that's going to be all real numbers for our domain. Okay? And we think about our y's also, they keep going, so all real numbers. Okay? Now, in interval notation, we know what that looks like. That's going to be from negative infinity to positive infinity. Again, the same thing with the range. Okay? And another way to write those again for the domain, we could say that x goes from negative infinity, it's less than positive infinity. And the same thing with the range could be written the same way. From negative infinity less than y less than positive infinity. It doesn't need 3 of them, does it, guys? That almost looks like an Audi symbol instead of a infinity symbol. There we go. Okay. All right, that's the first 4 we're going to look at. The next 4 we're going to look at, let me move my page up again. All right, here we go. Okay, Okay, the next one we're gonna look at, this is called a square root or a radical function. A square root or a radical function. Square root or radical function. Okay? The equation for a square root function is f of x equals the square root of x. Okay? Let's take a look. Notice this particular graph touches the axis right here at 0, 0. Okay? So let's think about our x's. My x's start at 0 and go positive and continue on. So that means x is greater than or equal to 0. Okay? So how do we write that in interval notation? We start at 0, a bracket at 0, comma, infinity, parentheses. Okay? If you have questions, write them down as in your notes you're taking them, and then you can either email me or when we have our Zoom meeting next week, you can ask the question. Next, we want to look at our range. Again, range is the same way. It goes up and down this way. It starts at 0 and works its way up this way. So it keeps going up also. So y is greater than or equal to 0. And again, our notation is going to be 0, comma, positive infinity, parentheses. Okay? Now, this one I think is the most challenging one of all. You have to remember what is not included in this one. Remember we did the disjoint inequality in our notes last week where we had something less than A and then greater than B? That's what you're going to see with this type of function. Let's take a look. This one is called a rational function. This is a rational function. Okay? The equation for a rational function is f of x equals 1 over x. Okay? Notice the x is in the denominator. Okay, so let's take a look at this. Here's our origin right here. We know this is x and this is y. This is our origin right here, 0, 0. All right, now notice the graphs. These graphs approach the x-axis and approach the y-axis, but they will never touch it. Both sides. This will keep going up and it will get oh so close to the y-axis, but it will never touch it. So therefore, it will never include the point of 0. So when we write the domain, we'll say all real except, my board's going a little wanky on me right now. Let's see if we can get it to act a little better. Except zero. All real numbers except 0, because it will never touch the y-axis here, or in this case, it will never touch the x-axis, which is at 0. Same thing about the range. It's going to be all real numbers except zero. All right? So, as I said, these two graphs will approach the x and y axis, but will never cross them. Okay? The next one we're going to look at is an exponential function. So, let's take this up a little bit. Let's take it off of me drawing on it for a second. Let's move it up. Okay, here we go. Okay, so this is an exponential function. Now, this is one you looked at in Algebra 1. So this is exponential. C function. Okay? Now, your equation on this one is going to be f of x equals 2 to the x power. So notice on an exponential function, your x is the exponent, okay? And again here, we notice our x values go on left and right. So that's going to be all real numbers. Okay, so again, our notation is going to be negative infinity to positive infinity with parentheses. Okay, now let's take a look at our y value here. This is similar to the rational function in that this graph is going to approach the y-axis, but it never will cross it. And that point is that line it approaches is called an asymptote. So in this case, the parent graph will never touch where y is 0. So in this case, y is going to be greater than 0, but it won't be equal to 0 because it will never touch it, okay? So if we wrote that in exponential, in a notation form, we'd have we would have a parentheses 0, because it doesn't include the 0, and it would go to positive infinity. Okay? And let's look at our last one. The last one is called a logarithmic function. This is a logarithmic function. A logarithmic function, okay? So in this particular function right here, your equation looks like this. It is f of x equals log, make sure I write it correctly, log x. So make sure I wrote that in correctly. Log x, okay? So when you look at this, we could even look at this right now. Let's take a look at our domain. Our domain, okay? The domain comes here to the x-axis right here, and then it goes this way, so it does not cross this x-axis for the parent function. So my domain is going to be x greater than or equal to 0. So again, we know our interval notation is going to look like this. Okay? And our range, notice it is all real numbers because it's going this way and then it's continuing to go up this way and it continues to rise a little bit on that curve. So it's going to be all real. Okay? And again, we write that as parentheses, negative infinity to positive infinity, parentheses. And you can also say negative infinity less than y less than positive infinity. So that's two ways you can write that. Okay? Well, that concludes our lesson today over the 8 main functions we're going to be using this year. Your activities will go with this. You will have one that has you practicing on matching the graph to the name. You will have others that will ask you different questions about them so you start to understand them better. Good luck on your homework.